Hi everyone, welcome to Hands-on Web Development with ASP.NET Core and Angular 7. My name is Ronald Adolph and I will be guiding you through the process of building an online store to sell DVD movies using the technology of Angular 7 and ASP.NET. A little info about myself. I've been a full-stack developer focusing on .NET technologies, Angular, Python, and much more for several years now. I also from time to time like to create tech events which involve some entertainment. I'm also the creator of the Full Stack Lab Bootcamp at ronaldadolph.com. To reach me, you could hit me up on Twitter and check out my YouTube channel. Now a quick overview of the course. It's going to be broken down into 6 sections. The first will be focusing on creating the Angular UI and setting up ASP.NET Core projects. The second will be on creating basic web services that we're going to be using. Section 3 will be focusing on structuring the Angular user interface, followed by Section 4, where we will be preparing the pipeline for the Angular store user interface. Then on Section 5, we complete the store, followed by creating some administration features. But let's take a look to see how it actually will look. A DVD store that you can navigate to see some movies that has some pagination. You can add content to your cart, view the cart, remove items from the cart, and there's a complete checkout process where you can go and complete your contact information, add credit card data, and place an order, to which you'll get a confirmation page. You're also able to filter out to see one type of category of film, in addition to having access to administration features that'll present you with a summary of number of movies that have been ordered in addition to for sale. And here you'll have the option to manage your movies, either delete some, create a new record of movies, or just edit what's already existing in there. And lastly, once movies have been ordered, you can come into this admin feature in order to ship them. So, I hope you're just as excited as I am. If so, let's go ahead and jump right into this and get our environment set up. Hi everyone, welcome to Section 1, where we will be creating the Angular UI and ASP.NET Core projects. To get started in this section, we are going to start setting up our environment. This is going to involve a couple of things. One is to configure our environment variables, and then installing the following: Visual Studio 2017 or a later version, but specifically the Community Edition, .NET Core, and Visual Studio, when installing that, will offer the ability to install .NET Core. But if you don't want to for some reason, you can install .NET Core separately. Next is to install Visual Studio Code, followed by Node.js and the Angular CLI. Now the first thing that we're going to want to do is to set our environment variables. And to do so, on the bottom left-hand corner, I can come and click this circle here and type in environment and select edit the system environment variables. This will bring up this window here, and we'll want to click on environment variables. And what you want to do is come under system variables, and if ASP.NET Core _ environment is not there, go ahead and add this in and specify development. If it's already there and it does not say development, just go ahead and click edit and just modify it. We're going to be working in our development environment, so we don't want to have misinformation to cause potential problems. The next thing that we want to do is to install Visual Studio, specifically the Community Edition. When you start the installation process, you're going to be prompted to select the workloads that you want. And the one that we really care about is all the way at the bottom here, on the bottom left-hand corner, .NET Core Cross-Platform Development. This will install the .NET Core framework itself. Now at the top here, you could see on the left-hand side, I also have ASP.NET and Web Development. You can go ahead and choose that. But the most important reason why we're installing Visual Studio is because it gives us the option to install SQL Server Express, which you can see under individual components. And if you scroll down under Cloud, Database, and Server section, right over here, the third to the last item, SQL Server Express 2016 Local DB is what we are going to need and be using throughout this course. The other thing that's nice about Visual Studio is that if you want to peek at your database content, you can use it with its SQL Server Object Explorer to view the content. All you need to do is click on that side tab and navigate to the server and drill down to your databases. Select your database. We're working with DVD movie. Under tables, I can go to one of the tables here like movies and choose view data, and we can see our content to just validate some of the progress that we're making. If for some reason you don't see SQL Server Object Explorer on the left-hand side, let me go ahead and close it, for example. All you need to do is go to the quick launch and type in just part of the name, object, and find it, SQL Server Object Explorer, and it'll come right up. Now I mentioned that you are able to install .NET Core on its own. To do that, you can navigate to this page here and download the SDK. And at the time of this recording, the latest available is .NET Core 2.1. Once I download that, I'll double click on the executable and install. If you get prompted by the user access control on Windows, just go ahead and click yes to continue. And that is it. I'll close. And to make sure everything went okay, I will now navigate to a command prompt by searching for, and what I like to use is PowerShell. And from here, to confirm that .NET installed correctly, I'll type in .NET and check for the version. And there we go. Now we can go ahead and move on to the next step, which is to download and install Visual Studio Code, which you can get from this site here. Now my operating system is 64-bit, so I'll go ahead and download this. Once again, I will run the executable and basically accept the license agreement and all the defaults. Visual Studio is a lightweight but powerful cross-platform code editor which runs on Windows, Mac, or Linux. It comes with built-in support for JavaScript, TypeScript, Node.js, and a lot of extensions available to add pretty much almost any other language, such as C++, Java, Python, etc. So now it's finished, and we have here that it's checked to launch Visual Studio Code. I'll leave that as is, and it did launch for me, and here we go. If it didn't launch for you, the way you can launch it from a command prompt is by typing in code dot. And actually right now it gave me an error. That's because it did not recognize the path. So I'll close it out and then bring up the command prompt again. PowerShell. I'll try it again. And here we go. Launches. Perfect. Now I'll close this out. Now our next step is to install Node.js. And we come to this website here to do that. Once again, I'll go ahead and choose the 64-bit version for Windows and run the executable. Accept the license agreement, choose next, and accept all the defaults. And Node.js is basically a runtime for server-side JavaScript application, and it's become a pretty popular platform for development tools. Node is used by Angular build tools to compile and prepare code that ASP.NET will send to the browser. All right, looks like we're finished here. I'm going to go ahead and choose Finish. I'll hop back to my command prompt, and to make sure that Node installed correctly, I will check the version. And once again, I get this error here. That's because I need to just put a new instance of the command prompt. And now when checking for the version for Node, by typing in node-v, we get that it's version 8. Now this installer also included the Node Package Manager, which is what we're going to be using to install Angular. And to make sure that that installed correctly, I'll type in npm for Node Package Manager and check the version for that. And that looks like it installed correct also. So at this point, we are ready to install Angular, specifically the Angular CLI, which is a command line interface. So I'm going to go ahead and just enter in the command for that, which is npm install. And we want to indicate that we're going to install it globally and specify Angular with the version. Now, as of the date of this recording, Angular 7 has not technically come out with a full release. All that's available is a beta, so that's what I'm going to be installing. But By the time you have this course, it probably will be available. And all you'll need to do is actually just type in Angular/CLI, just like this. But if for some reason it's still not, then you can specify the actual version that's available at the time. And now this will begin the installation process. The official site for Angular is over here. However, if you needed to look to see what is the actual latest version that's available that you want to try to install, you can come to this site right here on GitHub and check out the releases section. And as you can see, beta 4 is what's currently available for me, and that's what I added in my parameter. So it looks like everything is installed correctly, and to double check that it is, we want to check the version. And to do this, we type in ng version. And there you go, Angular CLI version 7. And now we're ready to move on to our next step, which is creating an Angular project. Okay, folks, so we are ready to create and review the ASP.NET Core and Angular project. So we're going to start off by creating the .NET Core and Angular application. Then we're going to quickly review the demo weather application that it creates by default. That's what we're going to use as a starting point. After that, we'll be reviewing the structure and files of the .NET Core application, followed by reviewing the structure and files of the Angular app. All right, so we are ready to create our .NET Core Angular project. Right now, I am at a command prompt, and what we're going to want to do is create a directory called dev, navigate into that, and now I'm going to go ahead and create a directory called DVD movie, because our application is going to be a DVD movie store, but I don't feel like having to write DVD movie store. So let's navigate into that. And at this point, to create our template application, all we need to do is type in .NET New Angular. Now there's lots of templates that's available, and in fact, to take a look at them, what you can do is type in .NET New L and hit enter, and you'll see the templates that we're able to use, starting from a console application all the way down to just a solution file. But what we want is right there in the middle, an Angular template. So I'll type in .NET New Angular. And the way that the command just immediately popped up is just by hitting the up arrow key, and that brings you to the last command. All right, now at this point, we can actually run it by typing in .NET Run. And now it's going to take a couple of minutes bringing in the node modules that it needs, which are some third-party libraries that Angular is going to be using. If we were to go straight to our directory for DVD movie, within client app, you'll see that there's a source folder, and the contents in here are essentially going to be where the majority of our client application is that we're going to be modifying. Now when I come out of it, you'll see that a node underscore modules folder was just created, and this is what's going to take a couple of minutes to build. In fact, if I go ahead and check the properties now for it, you'll see that there are currently 27,209 files, and if I check again, now we're at 31. But with the magic of video, we can skip right through this. So now you can see at the bottom it says it's listening on port 5000 and 5001. So I'll bring in a browser and type that in, localhost 5001. And here we see our new Angular application. It's a weather app that's a single page application with a couple of functionalities. One, it has a counter that demonstrates model binding without having to refresh the page. Once you click the button, it just increases. And then there's a demonstration of fetching data, which basically is just generating random data in a web API controller and passing JSON back to Angular, which then populates the view for us. In fact, why don't I go ahead and show you an overview of what's going on behind the scenes. I'll go ahead and stop this by hitting Control C. And now we can launch Visual Studio Code. Make sure you are in the DVD movie directory. Code, space period, and hit enter. Now you'll notice Visual Studio Code prompts me to add some assets. Specifically, it's for the C# extension. I'll go ahead and choose Yes. So let's go on down the line and mention what we see here on our left-hand pane. VSC code here, that's specifically related to the code editor, so there's nothing that we need to do here in relation to the app right now. This bin folder has your average bin directories and compiled DLLs that you may be familiar with if you're used to coding in .NET, the DLL and PDB files. This client app folder is where all of our Angular application is going to reside. But we're going to go ahead and jump back into this and review it. Right now, moving on down is the controllers folder, and that's part of the MVC architecture, and that receives input like HTTP requests, which initiates a response by making calls on the model object. But our use here is going to be limited. We're not going to have tons of model objects because we're going to be doing most of our work in Angular. However, if we were to open this, you'll see that we have a sample data controller. And in the weather app, this is where the functionality happens to lie. And right over here, the weather forecast method is where we create the random samples of the degrees that are returned back in a JSON format. Right below is the class for the weather forecast, which has a date, temperature, summary, and temperature in Fahrenheit that's converted. And at the top is some description of the temperatures, such as freezing, chilly, or cool, etc. And below the controllers folder is the OBJ folder, and that basically just has some .NET files related to debugging. This we won't be touching much. The pages folders is where you would have views and layout pages if we were going to be doing so, but we are not going to be. So let's move on. Below pages is a properties folder used to configure settings for IIS, profiles, and specifically this project. An example of a setting is the application URL and the ports, among a few other things. Now, www.root is where we would generally make static files accessible, like CSS or JavaScript files or images. Below that is this git ignore file, and that's basically used for version control. Here's where you can control what is updated, included, or excluded in your Git repository. Next, we have our app settings.development and app settings JSON files, and those are basically used to configure this app with things like logging. If we were to jump into there, you can see exactly what I'm referring to. Of course, it's not limited to just the logging, but that's just an example. The next file is just a configuration file for our project. And then we have our program and startup CS files. The program file, of course, being the starting point of the application. That is the starting part on the server side. And then we have our startup file, which allows us to build some more plumbing and configurations, such as specifying what services we want to use, in addition to routing, and an overall high-level description of how our application is going to be handled. All right, now let's jump into our client app folder. The E2E folder stands for end-to-end, and that's basically used for automated tasks that simulate a real user. So it simulates actions like navigating and clicking on a button, and that's what the files in here are used for. Next are the node modules, which we saw took a little while to download, but this is where we have our third-party apps that Angular depends on, and there's quite a bit of them. Next, we have our source folder, and our source folder has a good amount of code of our client-side application. If we open our app folder, here we have modules and components. Every app has at least one module and a component. You'll see app.module.ts, and then right above it, you'll see there's a few component files. One for CSS, another for HTML, and the TS stands for TypeScript, which is the language that we're going to be used that simplifies the process of creating client-side code without having to write explicit JavaScript. In fact, TypeScript compiles the code that we write in it into JavaScript. Now in our weather app, there were a few components. One was a counter that we saw, and another was to fetch data. And as you can see, there's a counter folder that has TypeScript files associated with it and the HTML files associated with it. And the same applies for fetch data, except in this case, it has one TypeScript file associated with it and one HTML file. But we're going to be creating our own components, so I'm not going to spend too much time with the structure of the weather app. So let's move on to the assets folder. This is generally where we would store image files and icons. Our environments folder is where we have configuration settings for different environments, such as production and development. The first one here being for production and the second one being for development. Let me go ahead and collapse the app folder here and continue on down the line. Next, we have our index.html, which basically has our Angular app. Here you'll see that there's no reference to style sheets or scripts. These will be dynamically inserted in the page when we run our application. Next, we have our main.ts file. This is the starting point of our client app. In programs, as you know, we have the concept of a main method, which is the starting point of a program. This is essentially serving the same purpose for Angular, specifically where we are bootstrapping the main module of our application, which is app module, and that's on line 19. The next file is polyfill.ts, which basically imports scripts needed by Angular. Polyfills in Angular are a few lines of code which make your application compatible for different browsers. Below that, we have styles.css, and this is where we would add styles for our app. Each component that we have, by the way, can have their own styles. And the next few files, test.ts, the files that start with tsconfig, and typings.d.ts, these are basically used for a testing environment, and we're not going to be touching those right now. So let me go up. I'll collapse now the source folder, and we'll finish up with the last few files. Angular-CLI, this is the configuration file for our CLI. We don't need to worry about that right now. Next, we have the editor config. Now, the purpose for this file is if you are on a team and you want to make sure that everyone uses the same setting in your code editor, this is where you would do it. Next is git ignore. We already talked about that, and this is related to how we can control what goes into our version control. The karma.conf.js file is used for testing. It's essentially a test runner. Package-lock. This file is basically automatically generated for any operations where npm modifies either the node modules tree or the package.json. Speaking of package.json, that is the next file, which is a pretty important one. This has the dependencies that our application needs. The protractor file is used to run end-to-end tests. We'll skip this README file. I think we all know what a README file is. The tsconfig file is used by the TypeScript compiler. If you ever need to change your TypeScript settings and how it compiles, this is where you would do it. And last but not least is tslint, which is used to check your TypeScript code. This is what allows you to show errors. All right, so that was quite a bit of information, but at least you now have a handle of what some of this content is. So let's move on now and actually modify the application so that we can have a good starting point for our DVD movie store that we are going to be building. All right, so now in this video, what we're going to be doing is mainly three things. One, we're going to clean up our UI so that we have very little content so that we can have a fresh start to build our application. So as you can see here in our UI, there's quite a bit of content here related to the weather app. Well, we're going to get rid of that. The next thing we're going to do is demonstrate how parts of the index.html file gets dynamically populated. So for example, on line 12, where we have the custom HTML tag app-root, how that's going to be populated. And the last thing that I'll show you is how our client-side code gets automatically compiled and our web browser page gets refreshed without us having to manually do it, which is a pretty cool feature. So in your exercise files, you'll have your starter kit that you can reference to paste in some of the code that I'll have if you don't feel like typing it in. But let's go ahead and start with a component, specifically the app component.html. Components define views, which are a set of screen elements that Angular can choose among and modify according to your program logic and data. We're going to start off with modifying a component, specifically the app.component.html. We don't need any of this to show, and if you could see, most of this content is here from the body content within the router-outlet. But we don't need any of this. In fact, all we care about is app-nav-menu. So I'm going to highlight all of this and put that within div tags. And you'll notice that in the browser, that content is gone now. The next thing we want to do is replace the content in a nav-menu.component, and we want to modify the HTML file. And we're going to get rid of all this, and within our div tags, we're just going to have the title of our application, which is a DVD movie store. So all we have is some div tags with some reference to classes that define how the look and feel should look by using bootstrap references. So now if we look at our web page, we see a DVD movie store. Now the next thing we want to do is back in our app component, we're going to add some more content, specifically a welcome to web development with ASP.NET Core message and the Angular logo. So on line 4, you can see I aligned it so that it's in the center. And within H1 tags, we have our welcome message. And on line 8, we have a reference to the Angular logo. All right, so looking good. One last area that we'd like to change here is to add some fields that's going to get populated later on for our movies. So I'll drop that in. And it's essentially just a table that's going to have the name of the movie, the category, description, and price. And if we take a look, we see how it looks in our UI. Now the fields below, we're going to address and populate them later on in the exercises. But why don't we go ahead and do a simple field right now for the title. We're going to go ahead and leave this here as just welcome to, and cut web development with ASP.NET Core and Angular 7 and create a field called title. And where this is going to get populated is within our TypeScript file for app component. So here you could see where app component HTML is referenced. And this section here from line 3 through 7 is a decorator. And you can see our welcome title has changed to welcome to app. Well, this is where we could go ahead and paste in our title that we actually want. And now it says welcome to web development again. So you see in the app.component, this is where you can consider this almost like a property. However, it's essentially a class with what's referred to as a decorator. Within the class, we can define our title. Within the decorator, we point to exactly what HTML file is going to be affected, in addition to the style sheet. And the selector, app root, is actually in the index file. The index file has app root here, and this is the area that gets dynamically replaced. And app root ultimately calls the app component HTML, which references the app component.ts, the TypeScript file. In fact, what we can do is actually make a change in the index file. I'll just jump over here on index.html. And why don't we make a style change? So within this body tag, let's create a div tag, and we'll change the background color by using the class bg-info. And as you can see now, the background color is no longer white, but a light blue. So as you can see, we've made quite a few changes, and everything was dynamically modified in our UI at the very bottom of the page here, which is great. And this is all done through Webpack. Let me go ahead and hit Control and backtick to bring up our terminal so you could see what's going on. You could see references to Webpack that were called, indicating that the compilation was being done, as you could see here at the very top of the terminal here, and then when it's compiled successfully at the very end. If we go to our browser and then go to View Source, you'll see what's been inserted. Now we have references to some bundles, one for inline, one for polyfill, one for vendor, and one for main. Those weren't there in our HTML file. If we take a look over here, we don't see that here. And that's some of the magic that happens with Angular and how it works with Webpack. You see, Webpack is a build automation tool, and it gets all our scripts, styles, and puts them in a bundle and then minifies it. So whenever you change your client files like a script or a CSS file or HTML, well, Webpack automatically recompiles your app and refreshes that bundle. And this feature of Webpack is called hot module replacement. So we've cleaned up our UI and got it ready for us to continue building on it. I've also showed you how some code gets dynamically inserted into some areas such as the index file, and then of course how everything gets automatically compiled and our pages get refreshed on the browser. But there is one additional thing that I'd like to show, which is if we were to go to our app component file, remember one of the files that I had showed you here on the left hand pane was tslint, and I mentioned how that helps us see errors. So let's say I had a typo over here. Because we have tslint installed, this provides us with the ability to see that something went wrong, which is pretty cool. It makes life easy, and it works just like it would in Visual Studio. All right, now that we have this portion set up, we are ready to move on to our next step, prepping the database. In this video, we are going to get things set up so that we can connect to our database. And we're going to be doing that by configuring our database connection. And as long as we're going to be in that location where we have that work done, it's also the location where we can set up logging. So we'll also address that. Now that we have our page up, the next step is to display some data so that we can have something that shows up for the name, category, description, and price. At least one record. So the first thing that we want to do is connect to our database. Now, communication with database is going to be handled with Entity Framework. And to provide Entity Framework Core with details on how to connect to the database, we're going to want to open up our app settings and create a connection string. And to do that, let's go ahead and just add a comma right here. And we will specify data followed by a colon and an opening up and closing a curly brace. And right below, let's now specify movies as the name of our connection string, followed by a colon, curly braces again. Here we'll specify connection string. And now right after another colon, we can indicate the parameters such as the server, which is going to be local DB. Make sure that's in parentheses. And just to save some time, I will go ahead and paste in the rest. So you could see on local DB, we're going to be creating and referencing a database called DVD Movie. We have trusted connection set to true, which allows for Windows authentication, and then multiple active results set to true, which allows the execution of multiple batches on a single connection. Now, here in the app settings is also where we can configure some logging. During development, sometimes it can be useful to see details of the build process for the Angular application and details of the queries sent to the database by Entity Framework. So why don't we go ahead and enable logging? And to do that, all we need to do is come up here on line 3 at the very end, hit enter, and we will put in Microsoft Entity Framework Core in quotes, followed by a colon, and in quotes again, information. Drop in a comma, and we'll do the same again, except this time it will be Microsoft ASP.NET Core Node Services. All right, that's it for logging, and our database is ready to be connected. So let's move on to our next step, which is to create some models. We're now going to create some models to represent our data both on the server side and the client. In this video, we're going to tackle the server side first. Specifically, it's going to be a series of C# model classes to create a database schema, which is going to be used to prepare our database to store the application's data. Now, an important difference that I want to point out from the conventional ASP.NET Core development is that we're not going to create a repository interface and implementation class in C# that is on the server side. Instead, we'll later create the repository in the Angular application, the client side, which is where the data is going to be consumed. So to get started, what I want to do is at the root of our project folder, DVD Movie, we're going to create a folder called Models. So make sure it's at the root and it aligns at the same level as controllers. Within here, let's go ahead and create a new file called movie.cs, which will serve as our model for our movie class. Here I'll set up a namespace called DVD movie.models. And within here we can set up our public class called movie. Now the first property that I'd like to set up is our movie ID, and it will be of a type long, and we can indicate get and set. So this is pretty much the basic structure, and I'm going to go ahead and add in the rest of the properties that I have. Again, you can reference the starter kit if you want to just copy and paste these properties. Now for list here, I'm going to go ahead and hit control period. It's complaining because the namespace needs to be imported, and that is the collection's generic namespace. And now it just added it. For studio and rating, those are classes that we need to add. So let's go ahead and do that next. Studio.cs, and I will paste in our class and properties. And now I'll create one more for rating. So rating is going to be used to, as the name implies, give our movies ratings, and it'll have a rating ID associated with it, the number of stars that the movie has, and of course a property to reference the movie. Now let's jump backwards to where we were on studio. Studio obviously is going to have a studio ID also, a name, a city associated with it, and a state. This is the movie studio that creates the movies. An example is like Paramount. And the last property is a collection of movies that the studio is responsible for. And of course, our first class that we created, movie, has a movie ID, the name of the movie, the genre, I'm referring to it as a category though, a description of the movie, which is usually a short log line, and the price of that movie. And that's going to be the price of the DVD. And lastly, there's the studio that created the movie, along with the ratings that it has. So these are the models on the server side that's going to represent our data schema. Next, we're ready to populate the database using this schema along with some sample data and registering the database context. Now that we have our schema set up, there's a few things that we're going to do in this video. We're going to set up the database context class that's going to allow us to see the data. Then we're going to add a class with some sample data. Then we'll register that context and then finally test it to see if we can get some data back. So the first step is to create the database context class that provides access to the data through Entity Framework. And we do that by going to our models folder, and within here we'll create a class called datacontext.cs. Now we're going to be referencing Entity Framework, so let's import that namespace. Next, we'll define our namespace, dvdmovie.models. And within here, let's start by defining a public class called data context. And whenever we are working with data context, we generally need to implement the interface dbContext, and actually need to specify that this is a class. Otherwise, the code won't know exactly what's going on. Next, I'll specify public data context and specify db context options. And within the brackets here, I'll indicate data context, OPTS for options. But right after, I will indicate that I'm referencing the base and passing in the options. And we end it with curly braces. Now I can go ahead and specify my properties of DB sets, and these reference the table. So I'm going to indicate the first one as movie and refer to it as movies, and indicate get and set. And I'll do the same for studios and ratings. So what's going on here? This context class follows the standard pattern for Entity Framework Core. And on line 5, I'm defining a constructor that accepts a dbContext options object, and that is configured during ASP.NET Core startup sequence. And then there's a 3 dbSet properties which provide access to the data in the database, and as a result allowing independent queries for each model type. The next thing we're going to do is create our class so that we can seed the data. And I will call this seed data.cs. And here we have a lot of content. So I'm going to copy everything right from the starter kit, which you can do also. And let's explain what's going on here. Starting on line 10, we have our seed data method, and that starts by calling the data context database migrate method, which ensures that the schema in the database is up to date before the seed data is applied. Now, the rest of the method creates a series of model objects associated with one another, and then at the very end, as you can see, we have several studios, 3 of them, and then several movie definitions. And at the very end, we save everything to the database using context.savechanges. Now, the next thing that we want to do is register the context class with Entity Framework and to ensure that the seed data is applied when our application starts. So to do that, let's go to our startup class. And at the very top, we're going to want to import our DVD movie models and reference Entity Framework core. Once we do that, we can go to our configure services. And at the top of the method, what we want to do is within services, invoke add DB context. We'll reference our data context and then use SQL Server pointing to our connection string. And that's done by invoking it within options. After having done that, we can hop on over to our configure method, which is towards the bottom, starting on line 39. And at the very end of it, we can then reference seed data and invoke seed database and pass in our context. Now, context isn't showing right now. That's because within our configure method, I actually need to reference it and pass it in as a parameter here. And of course, the type is data context, and we'll call it context. And now there should be no complaint after adding the semicolon, of course. All right, I'll go ahead and save. By the way, most of the times I've been saving by using Control S, but you could always go to File and select Autosave so you don't have to worry about that. Now at this point, a database migration is required to create the database schema that will allow the database to store information. And to do that, we can go to the terminal and type in .NET EF migrations add, and we'll give it the name of initial. It's our first migration. And what you'll see is on the left-hand side, a folder will be created that's called migrations. Let me go ahead and collapse all these folders here, and then I'll hit enter. And there we go. Right above models, you see that we have a migrations folder with some associated files to keep track of our database changes. So now we're actually ready to do the last thing in order to test pulling some data. So we're going to hop on over to our controller. The first thing we'll do is add in a namespace to reference our models. And here I'm going to go ahead and delete these references to the weather app because we're not going to be using them. In fact, what I'll do for now is just comment them out by going to Edit and Block Comment. And now I will add in a couple of code snippets. The first is to reference our database context. As you can see, I have a constructor here that passes in the database context and assigns it to context. Next, I'm going to have a method to actually use it, and I'll call it getMovie. And it's decorated with the attribute of HTTP GET. And all we're doing is invoking our context, accessing movies, and going to be querying for one movie based on the ID that's passed in. Now, the way the routing is set up, I'll have to access the content with a URL that points to the API. And then, as you can see here, it references the controller. So it'll actually have to say the API/sample data, which is our controller, and then the method that we want to invoke, which is getMovie. So it will actually look like this. So now in order to execute it, before we actually run the application, we want to update the database. And we do that by typing in .NET EF database update. And that's actually going to populate the database. And at this point, we can do .NET run. Let's bring in a browser and enter in our URL for the API, invoking the get movie method. And it looks great. We got data. It's in JSON format, but we are at a nice starting point where we can now move on to modify this to be used in our UI. And in order to do that, we need to create our data model for the client side in Angular. That's up next. Now that we're able to access data, we can now move on to creating the Angular data model, which will be used to consume the data that we set up in our last video. So in this video, we're going to be creating the models that we need. Then we'll be setting up a feature module and also configuring our root module, which is located within the app module TypeScript file. Okay, so now we are ready to start creating a model on the Angular side. And creating a data model in the Angular part of the project makes it easier to work with the data that's received. So let's go ahead and get started by creating a movie.model TypeScript file. And it's going to be created in the models folder within our app directory. So under our client application, source, app, let's go ahead and create a folder called models. And within there, a file called movie.model.ts. And now I will go ahead and paste in the content of our movie model. Now, let's go over what's going on here. The first couple of lines is to import the references that we have to our studio and to our rating models, which we haven't created yet, but we will right afterwards. But focusing just on this class here, as you can see, starting on line 5, it contains only a constructor, which is typical for a TypeScript data model class. TypeScript constructors are denoted by the constructor keyword rather than the name of the class, but they perform the same purpose as a C# constructor. And each parameter receives a value that can be used to configure a new instance of the class. And within here, you can see all the properties that's associated with our movie class. Now I'm going to go ahead and create 2 more, one for the studio and one for the ratings. I'm just copying and pasting the movie model. I'll highlight this one right here and basically rename it to studio.model.ts and basically replace everything that's in here with content that's relevant to the studio. Next, I will rename this file here to rating.model.ts and replace this content as well. Now, in order to use our repository, we need what's referred to as a feature module, specifically an Angular feature module, which is used to group related functionality together, such as the data repository classes in the data model. And using feature modules makes Angular applications easier to manage and maintain, although the real benefits are available when you're working with Angular building blocks such as components. Now I'm going to go ahead and create a feature module so that the data model can be easily integrated into the Angular application. So I'll create a file here called model.module.ts. I'll paste in our code and let's talk about this. Now the code here defines a TypeScript class called model module, and that class has no properties or methods and is just a vehicle for the decorator, which is used to provide Angular with metadata about a building block. And that decorator starts on line 3 where it says @ngModule, going through line 5. And this type of decorator tells Angular that the model module class is an Angular module. Here you'll also see that there is only one configuration property in this decorator called providers, which is used to register classes for dependency injection. So just like ASP.NET Core MVC, Angular allows application building blocks to specify the services they need using their class constructors. And these dependencies are resolved via dependency injection, using the classes that are registered in Angular modules providers properties. So the way that we have things set up here, other parts of the application are now going to be able to use the repository object using dependency injection. Now, our next step is to configure what's known as the Angular root module. Let's go ahead to open up a file called app.module. Now, the root module is a special Angular module that configures the entire application. One of its roles is to give Angular details of the feature modules that the application requires. And in our case here, what we're going to want to add is an import statement for what we just created, the model module. And in order to use it, we go into our imports, and we can go right here under HTTP client module and specify model module. And that's it. Now, in case you're wondering about the main structure of this, well, the root module is defined by applying the @ng module decorator to a class called app module by convention, and it provides the configuration of the application using 4 properties. And those properties include declarations, as you see on line 15, imports starting on line 22, providers, which you see on line 33, and then bootstrap on line 34. Declarations, this property is used to provide Angular with a list of the building blocks used in the application. Imports is used to specify the Angular modules that the application requires. Providers is used to specify services for the dependency injection feature, and Bootstrap specifies the root component of the application, which will be used to start the application. Okay, so now we're in the final stretch and can move on to displaying the data. That's up next. In this video, we are now ready to make the changes needed in order to display some data. And in order to do that, we are going to be updating our component to use a repository we set up. We'll also review the anatomy of a component, in addition to discussing a little bit about data binding. And then lastly, we are going to test everything that we've put together so far in order to see if we successfully can display data, specifically a movie record. So, the basic plumbing for the Angular data model is complete. We have our repository that has been configured for use with the Angular dependency injection feature. Now, our next step is to use the repository to get the data and display to the user. And in an Angular app, the key building block is a component, which provides the logic and data required to display HTML content to the user. And the component that we care to look at right now is this one, app.component.ts. Our goal now is to provide the component's template with access to the data in the repository so that it could be displayed to the user, which is achieved by making 2 additions to the app component class. So the first, before we even tackle those 2, they're going to refer to the repository and to our movie object. So let's go ahead and import repository and our movie model. And now we can move on to our first modification, which is adding a constructor that defines a private variable repo and references our repository. We need to make sure that we end it with an opening and closing curly brace. So this constructor has a repository parameter called repo, which is how dependencies are declared in an Angular app. The parameter tells Angular that the app component class needs a repository object and provides it when a new app component object is created. The next thing that we need to add is a property, specifically a read-only property for movie. And we just need to write get movie, opening and closing parentheses, followed by a colon, specify movie with a capital M, and within here, return this.repo.movie. So this is the second addition. And like I mentioned, it's a read-only property, and it's called movie. And what it does is it returns the value of the repository object's movie property. And notice that the this keyword is used to access the repo property. The purpose of the whole app.component file is to define the class called app_component that you see on 11. And you could always tell that this is a component because it's been decorated with the @component decorator on line 6. And that provides Angular with the configuration settings that are required to make the component work. There's the selector, template URL, style URLs, or you can say style URLs. For the selector, this property is used to specify the HTML element that the component will be responsible for managing. So for this component, the selector property tells Angular that the component will manage the app root element that can be found in our index HTML. So if I navigated down to index.html, you'll see on line 13, app root. Now in respect to template URL, this property is used to specify the component's template, which is the HTML content that will be displayed to the user. And that is app.component.html. If you recall, that had this content here. And then the last thing is style URLs. This property is used to specify one or more style sheets that'll be applied to the component's template content. So the last thing that we want to do is hop on over to app.component.html. Here is where we display the data to the user. Now we can talk a little bit more in detail about the syntax here that you've seen earlier on in the course. This fragment of HTML relies on an important Angular feature. That's the data binding. And data binding incorporates data provided by the controller into a template, and in this case, displays the value of the properties defined by the movie object returned by the component's movie property. Now I used a fairly basic type of data binding in this example, which is denoted by the double brace characters, such as you see on line 18 that surrounds movie.category. And if you're wondering what the question is, that works just like in C#, and it essentially just checks for null. So if category is null, it is not going to try to write it out. And that's it. So let's go ahead and run and see what we've got. We'll put in our local host. I'll hit enter and see what we've got. Excellent. We got our UI and we've got real data coming back. And it picks the first record, which is the movie Titanic. One of my favorite movies, and I have no shame in that. So we finally reached the end of section 1, and now we are ready to move on to the next section where we will be creating a web service for the Angular user interface.